Good morning. This is your instructor from Current Instrumentation. I am in classroom today, as you can see, but they haven't arrived. I was a little early, so I'm stealing this time to give you a little lesson, a little sneak peek. You can see our CEO in the picture that appears briefly holding two transmitters. Now, one of those transmitters is a $500 device. The other one is a couple thousand or more. And you would wonder, why would somebody pay that much more for a device that does exactly the same thing like the other? They're both sensing a pressure from a process, their instruments, their instrumentation, and they have a transducer that converts that pressure into an electrical signal, goes on to be, say, like a 4 to 20 milliamp signal, goes to a control system. Now that's where the similarity ends. Let's talk about why the larger transmitter is more expensive. Number one, it has a display, so you can actually read those values in the field without having to call someone in the control room with a radio. Number two, accuracy. Accuracy of a smaller screw-in type pressure transmitter, typically something like 0.5%, whereas these higher end devices, you're talking 0.05%. So that means they're 10 times more accurate. What's more, next point is hysteresis, is when a instrument is reading a pressure going upwards and then reading the same pressure going downwards, it should read exactly the same value, regardless of the direction the transmitter is going in. Some transmitters struggle with this and they're not accurate. Going up, they're 0.0 something off, and the other ones are bang on, like the more expensive transmitters. That's called hysteresis in a curve. Next point is drift. Over time, over 10 years, 12 years, you have to recalibrate a cheaper transmitter because its calibration has drifted, whereas the more expensive transmitters, they are very stable, their electronics and their construction. They have something like a 15-year stable with the negligible drift reading on their readout. We're also talking about higher costs due to accuracy achieved by turn down. A turn down ratio is something like gears in your car. The more, or in your wristwatch actually, the more gears you have, the more accurate, as in it takes 60 rotations for the outer gear to make the inner gear rotate just one notch. So the more turn down you have, the more accurate you can make your system, because you're dividing a timeline further to make a certain timeline, or in this case a pressure reading, more accurate. What else? There's instruments that have a NACE rating. NACE stands for sour service. Corrosion Engineers, National Association. Whenever instruments are used wherever there's sour gas, H2S, that will start to eat up steel. So if it's NACE certified, you know it has better stainless steel alloy that will not get corroded by hydrogen sulfide. And instruments that have to be used in hazardous locations for incendiary atmosphere, such as flammable gases or coal dust, etc. They have to be housed intrinsically safe or explosion-proof or flame-proof housings, so that the instrument can operate with integrity, and nothing from the instrument is capable of igniting incendiary vapors outside of the instrument. Next is, some processes are very demanding, or some exteriors are extremely demanding, seawater, etc., or hydrofluoric acid. So some of these expensive transmitters use exotic alloys like Monel, K-Monel, Hastelloy 276. Those are very expensive to make, and they push the cost up of the transmitter, but they make your transmitter very reliable, and they become like fit and forget instruments over the years. That's a little summary from your instructor, Sam Pherwani, at Current Instrumentation. Have a wonderful rest of the day. Goodbye.